Hello everyone. So from my last attempt to create an agentic AI agent to this one now, another agentic AI agent that I've created, which is again not a workflow but thinks for itself. The difference now is that I'm using a different use case. I'm using more agentic classes, and I'm using a LLM router in itself. Right. So today I'll take you through Agentic VC Analyst, which takes a pitch coming from a startup, somebody who has an idea, and then creates a whole result out of it, that if you should invest in it or not based on various reasonings, various SWOT analysis, risk, assessing competitors, and then again gives you a verdict. It should be a watch list, you should invest, you should not. But more important than what this agent does, I would want you to I would want to take you to through the workflow that I've designed, or not just workflow, but rather what the agent is doing and thinking through this whole uh, running process. Right. So the idea is the founder or whosoever pitches a startup idea in plain language. The first step is to convert that into structured thesis and figure out what's happening next. So there are two loops which runs. One is research, the other one is synthesis. We'll get to synthesis, but first one is research, right? Research is where this agent thinks. Uh, Look up, creates a logic, plan, verify itself, and then synthesize a plan which is the next step, next large step. A very important thing while it's thinking, it kind of self checks after every step. So it creates fallbacks, it creates verification, and if something goes wrong, it retries, right? So as I said, it's a thinking mechanism in itself. First step is to pick a brain. When I say a brain, to pick LLM models, and this in this one I'm using two of them. One is OpenAI, which I'm paying for, and the other one is Gemini, which is free. So how I programmed it is to make sure that because Gemini is free, so the number of tasks which are high but which are low complexity, let us do those through Gemini. But when complexity becomes high, we'll hit OpenAI. And it really helped me through building this, because whenever my agent was failing, and I had this number of times when it went into a loop, and whenever it went into a loop, it was only hitting Gemini, which was free for me, right? So it was not costing me dollars, but I had to create mechanisms to make sure that it does not loop. But while even testing, it was really helpful. So the first step is to pick what LLM to use, then depending upon the complexity of the task, but then we pick up a tool which is coming from the MCP that I wrote. So it has tools like search web, extract competitor, validate claim, flag risk, cross reference, and prioritize gaps. Right. Based on the tool that it picks, it acts, right, and the tool runs from the MCP server. Then it ingests all the facts that is coming from those as the output from the tool. After running every tool, it checks if my confident if am I confident enough to be able to synthesize a thesis out of it or a decision out of it. If not, then I go back, dig in again, right? And that's the loop that continues to run until and unless it finds enough information to say that yes, I can build some synthesis out of it. But and when it is confident enough, it goes into the synthesis loop, and which maximum is 14 turns, which I've programmed it to do so. You can reduce, you can increase, right? And in this synthesis loop, it calls other tools that are coming from the MCP, which are creating a SWOT, creating a differentiation matrix, creating a risk matrix, and then finally creating an investor memo, which an investor can use to make a decision and also suggest a decision, right? So at every tool when it runs, it checks if everything is ready or not. If not, it goes back and does it again. And at each given point of time, it is figuring out does it have enough information to do so. If not, then it might go to the research loop again. And when it does have enough information, it creates a final report, which is the investor memo, SWOT, risk differentiation, and the obviously the log and the final verdict of the agent. Right. So that is what it is doing. I ran two uh, tests and I actually ran multiple tests, but these two are which I'm showing you. One is B2B SaaS tool that helps small restaurant owners to manage their staff. The other one is the autonomous agentic AI system to navigate drones. And the result that came out was very different. For the drone idea, it says strong invest, and for the restaurant idea, it says watch list. And in this particular UI, I laid down all the steps that it went through, and you can also obviously download the log of this agent and what it went through, what it did, how many loops it ran for. I downloaded all the logs for these two trials. I fetched that to Claude and I asked for it to understand that if the agent is behaving differently for two different problems or not, because I wanted to understand that does it adapt to what the problem that it is given for. And Claude helped me to understand that yes, it did, right? For different use cases, while it was not confident enough for autonomous agentic AI for drones, the agent recognized it was vague and it has a complex pitch. It has a regulatory angle to it. So it asked for regulations and ran search loops for understanding regulations, while it did not do the same for restaurant pitch, where it was slightly more confident, right? One of the important thing that this agent did was a self-correction moment, right? So after a few runs, when it sees that I am not getting enough information, it corrects itself, and it probably tries to do something else to be able to understand, can I get to a verdict with less information? And just because of less information, the restaurant verdict is watch list, right? So different verdict, different synthesis path. It ran for 13 turns for one of them and 15 turns for the other, and moved one to strong invest and other one to watch list. So this is going truly agentic, where on the go, our agent is thinking, our agent is trying different things, and trying to figure out what is the best next step for it to do, and also to figure out what is the best possible LN that I can choose given the complexity, given the limits that it has, given the number of trials and tokens that are being used for this particular right. So that is what I've built. I'm trying to do this. This has a lot of improvement scope, obviously, a lot of things that I need to tee up for it to become a product. But it's an attempt to go truly agentic and get some understanding of how Pydantic, NCP, and an agency to a given LLM helps to drill down your task, make it think, and pick up the best result. So let me know your thoughts. Let me know how you would do it differently, and it'll be really helpful. Thank you so much.